I'm here to talk about Blockchain 101, and this is going to be a very straightforward talk about the very basics of blockchain. Most of you would already know about most of these, so just wanted to have this brief discussion with the folks here. Great. So, so the first thing that I want to say is I just want to clarify a big confusion, which is blockchain is not the same as Bitcoin. Blockchain is to Bitcoin what internet is to email. So, blockchain, not Bitcoin. Bitcoin is just one application that is enabled by blockchain technology. So, what is a computer network? Computers are really good at sharing information, and that information means text, pictures, videos, websites, etc. You can share the same thing to different people, right? And this is what a computer network is very good at. But what a computer network is not good at is ownership of assets, right? Transactions, money, because if you have an open computer network and if it's made for just sharing content, right? How do you share money on it? How do you transact on it? So there's this thing called a double spend problem. So let's say you have a cat photo and you give it to one person and then you can give it to another person as well. But you can't do that for money. And that is why a computer network natively is not very good at these things. So how can you make it that you send something to someone and then not be able to send it to someone else? Right. So then you have a centralized network. So there's a central server that stores the data and keeps track of the ownership data. So then everyone requests the server to update the data, which means let's say your banking data or your balance is on the bank server. And when you do a transaction, the amount is deducted from your account and credited to another person's account. So this is simply an update in a database. And the server, which in this case is the bank, makes sure that you cannot double spend. And when I say double spend, it means let's say you have 1 rupee, you can't give it to two people at the same time. So this is the job of the banking server to ensure. But then what could go wrong, right? So then these things become the central points of failure. So bank is one example. Let's say there is some other company who's holding your credit card information to be able to charge you and all things like that. So then these servers become central points of failure, right? And then they also open up the opportunity for seeking a high rent, which comes in the forms of commissions or fees on anything that you do and things like that. It's also easy to freeze your assets. Imagine you having your money, but then someone comes in and they say that the money is demonetized, and in that case, you can't even access your own money, right? You have to stand in long ATM lines to be able to access it, even though that is your money. So why this is happening is because there's this central point of failure. There's this central point which is in control of someone, right? And then there can be corruption and fraud, right? You might say that the fraud is illegal, but it's illegal only if it is caught. So if you think about the PNB loan scam and things like that, so all your money is sitting in a bank, and then it was given out to people who were not eligible for that loan. So because all of this is centralized, right? There are these central points of failure, and of course there are these privacy breaches and data hacks. So if all your Aadhaar data is sitting on a single server, that server becomes a honeypot for hackers. And then what they do is, so it's easy to like attack that server and gain a lot of data. So this is what goes wrong in, when we're talking about central servers that keep ownership data or your ID data and things like that. So the question that we ask ourselves as technologists is, can we do better, right? Can we replace centralized authorities? Can we trust each other to agree on who owns what? So not being reliant on anyone to tell us who owns what. Can we trust each other? And what if we could replace the legal protection of our assets with technological protection? So there's this there's this economy, like the financial network and economy, and all of that is protected by the laws that are in place, right? And those have to be enforced. But what if you could define a technology that allows you to write the laws in code, and because that is written in the code, it cannot be hampered, it cannot be tampered with. So yes, we can do better. So centralized versus decentralized networks. I drew the distinction just now. The centralized network is like one data source that everyone is interacting with. In a decentralized network, there is no single data source. So a perfect example of a decentralized network is a blockchain network. So a blockchain network is transparent, which means each node in the network has a copy of the blockchain. It is secure. So it uses cryptography and digital signatures to prove identity and enforce read and write access. So basically, all the ACL, which is the access control, is defined in code, and it is guaranteed by cryptography. And it's immutable, which means there is a consensus mechanism, and it makes it hard to change records in the past. So you can't really reverse transactions or things like that. So what is really a blockchain? So as the name suggests, it's a chain of blocks. So list of records stored in blocks of data. So when I say list of records, in case of Bitcoin, that is simply transactions, where a transaction is, let's say I gave someone five Bitcoins. So that would be a normal transaction. And then each block contains a series of transactions, right? And then each of these blocks is chained together in form of a chain. This is why it's called a blockchain. So let's talk a little more about Bitcoin. Bitcoin is the world's first decentralized peer-to-peer currency. It is scarce. So Bitcoin supply is capped at 21 billion. And this is a very important property of money, right? If there was if there was something that you're using as money, but that thing can be easily produced, then that is not really money. So because it's not a good store of value, which means you have your money, but if I can produce it in another form, if let's say I could print it, or let's say if you were using glass beads or seashells as money, I could simply go to the ocean and get seashells from there. So then the seashells that you possess, they do not hold any value anymore because it's so easy to get seashells. So any kind of money which is sound needs to be scarce, and BTC is scarce. Money needs to be portable. So because Bitcoins are online and internet connection is all you require for transferring them. Imagine using gold as money. You would need to carry huge blocks of gold everywhere, and that is not portable. Bitcoins are divisible. So each Bitcoin can be divided into 10 raised to 8 pieces, which is 100 million pieces. And another, that is a property of money. It needs to be divisible. So if, again, you were using blocks of gold and you had to pay like 1 cent, how do you cut that block of gold and then pay with it? Authenticity verification. So BTC are online and the ledgers are public. So it's very easy to verify authenticity. It's simply a matter of running a Bitcoin node or just probing the blockchain. Whereas in case of a traditional bank, even though you would assume that because there's a number in your account, but you're not really sure where that money is coming from, right? But in Bitcoin's case, it's verifiable. That's the point that I'm trying to make. So blockchain consists of two things conceptually. It consists of a distributed ledger, which is a series of blocks and transactions that I spoke about. And other than that, there is a consensus mechanism. So because this network is decentralized, right? You need a way for the people to be able to agree on something. Because if you make an update, what if you agree with it, but other people do not? So there has to be this agreement mechanism in place, which we call consensus. And only when that is achieved, the Bitcoin blockchain or any blockchain for that matter is changed. So a list of transactions between accounts are stored on distributed nodes. So think of it like a central server has only one copy of the data. Decentralized network, the copies are like everywhere. Lots of people have it. and new transactions are periodically added into the block, which are then chained together, right? And nodes use an agreed upon protocol to reach consensus on when a new block is appended to the chain of previous blocks. So because it's decentralized, lots of people could say that no, this should be the new block, this should be the new block. But there is a way to be able to verify those blocks and say that, yeah, this is the right version of the blockchain. And that is what we call the consensus mechanism. And so there's this first consensus mechanism called proof of work. And how it works is, for a transaction to be considered valid, it must go through a computationally intensive validation process known as mining. And mining is simply doing a mathematical problem that is quite hard. It's not hard, it's just that it takes a lot of time to compute. So it's like some kind of computation. It's like your computer is solving a math problem, and when that math problem is solved, it can be said that the that a new block was mined, which means a new block was added to the blockchain. And a good property about this thing is, once a block has been mined, that puzzle has been solved, it's very easy to verify that it has been solved. But it's not easy to do it again, which means if you solve it, and in the Bitcoin blockchain, it takes about 10 minutes to be able to solve that puzzle. So every 10 minutes, someone is solving that puzzle, but you can verify instantly that they solved that puzzle. So this is the property that is used here. So then it becomes very easy to verify the blockchain, but not change it. So then came Ethereum, right? Bitcoin was this first generation blockchain, and there were all these guarantees about transactions where you assume it to be decentralized, censorship resistant, and all of that. But Ethereum takes it a step further. And what Ethereum does is, it gives you these guarantees for code execution. So let's say you had to make some kind of a service that you do not want people to trust, but you want them to be able to verify, right? Some kind of sensitive financial service or things like that. Instead of running that code on a central server, if you could somehow put it on the Ethereum blockchain, people would be able to verify what the code is and interact with it if they want to. And all of this happens in a decentralized and censorship resistant fashion. So basically, all the guarantees that the Bitcoin gives for transactions, Ethereum gives those guarantees for computation. And that's why that Ethereum blockchain is so interesting, because you can do a lot with it. And how Ethereum works is, it's a transaction based state machine. So state machine is a program that reads a series of inputs and then modifies the state. So if you were state one, there are a series of inputs, and then that is processed and you reach a state two. So this is what a state machine is, and this is how Ethereum works. So for Ethereum, these inputs that I'm talking about, they are user initiated transactions. And when I say transactions in the context of Ethereum, it doesn't mean only value transfers. It also means executions of those code pieces that I spoke about. So all of that is called transactions in context of Ethereum. And because it's able to possible, it's possible to write a lot of code on Ethereum blockchain, right? It opens the possibilities to write different kinds of applications, and the community calls them decentralized applications, or dApps, right? And what you can the kind of things that are being built on Ethereum and that you can build as part of this hackathon is like a decentralized exchange. So when I say exchange, it means a utility or an application where users can convert between cryptocurrencies and tokens, right? Prediction markets. So prediction market is just a fancy term for betting markets, but yeah, it's very interesting because if you build a betting if you build a betting market on Ethereum, it's like very easy for people globally to be able to bet on things. And then, right now there's all this regulatory hurdle about how do you make a betting thing, and how do people transfer money from their countries to that betting platform, right? Because cross-border money transfers are still hard, but you can do that on a blockchain. Distributed computing, and then identity management, cloud sale platform. So this is one of the most popular use cases of Ethereum, where what companies are doing is they are trying to raise money on the blockchain. right? Instead of going the traditional equity VC manner for raising funds, they're actually introducing a token, which is you can think of it like company equity, and people buy that. And the company promises that if you have our token in the future, you can use it somehow. So let's say a decentralized exchange introduces a token, they could claim that our token can be used to pay fees on the exchange. So this is another use case, and some more. So digital governance, there's a project called Aragon who's building a framework to be able to spin up decentralized organizations on the Ethereum blockchain and things like that. So basically, the possibilities are endless, and it's a great opportunity. ETHIndia Online is a great opportunity for all of you to like explore these things. So yeah, that was about Ethereum and blockchain, right? But another question that is yet to be explored is, why is blockchain important? And this is something that I would like to discuss about. So the problem of data integrity, right? The problem is, without a central source of truth, what can you trust or whom can you trust? The solution is a peer-to-peer network that's costly to add and change data to. So because this network is kind of immutable, because the updates are hard, there's some kind of guarantee about the authenticity of this network. And doing all of this imagine doing all of this using technology, right? And not just having a law framework that enforces things. Yeah, so just a thought. It's like acting without integrity costs a lot more time, energy, and reputation than what building a peer-to-peer network does. So it's probably a good investment to build a peer-to-peer network instead of trying to you know act around wrongdoings on a centralized network. There's distributed power, so no person or organization has outsized control over the whole. So for a good example here would be internet. Our internet experience is governed by a few companies, right? Google, Netflix, Facebook. These companies define how your internet experience would be because they have that kind of infrastructure in place. 50% of the routers in the world belong to Netflix and Google. So not very cool. Like, why does one person organization have control over all of this? Because the downside of having this is there are incentives. So if I control a large part of some market, there are incentives for me to manipulate those markets or seek rents. And I'll always try to. So how do I even introduce protocol changes? I, as a company, would introduce protocol changes only in a manner that would be beneficial for me, right? But I would not think about internet as a public goods, and hence this is something non-ideal. So again, the problem is a third party being the source of truth can lie, but the solution is the users participating in the network maintain the network. So it's like having real skin in the game. If you're part of a network, you also contribute to maintain it. So it's all about aligning the incentives, which brings me to aligned incentives. So people are driven by different incentives, right? And if those incentives are not aligned, it often becomes a problem. So if you think about it, right, how Bitcoin works is miners in the Bitcoin blockchain are just trying to maximize their payout. All I have to do is I have to solve this mathematical puzzle. And when I solve that mathematical puzzle, I get rewards in Bitcoin. I just care about that. I just want to earn my Bitcoin. But the incentives are aligned in such a manner that even though when I'm trying to do this, it helps the network live. So when I'm mining a new block, I get my reward. I don't care about anything else. But what actually happens is I add a block to the chain, which is what like everyone wants. So it's good for the network. So if the incentives are aligned in such a manner that even though I'm trying to maximize my payout, but in the end I end up maintaining that network. So this is giving people real skin in the game. And if you think about it, this is very interesting way to go about things. So it's all about aligning incentives. If you give a task to a particular person, and if they have the right incentives, they'll do it. But if not, they probably won't. So yeah, the solution is to give rewards for providing proof of work. People will have a vested interest, which is earning bitcoins, but they'll end up maintaining the network. Security. So the problem is hacking, fraud, identity theft. Your credit card data can be stolen, your identity data can be stolen. But how do you solve it? You solve it by having this public private key pairs and people owning their own data. And in that case, there is no honeypot for you to be able to hack, right? And there is privacy. So data exposure to prove your identity is the problem. So when you do a sign in with Google or similar user flows, you often share a lot of data, right? And then the problem is, even if Google was acting rationally, you have to give all your data to Google, which might not be ideal. So the solution is eliminate the need to trust others and eliminate the need to know the true identities of those others in order to interact with them. So what if you could remove the identity part of interaction? And what if you could simply align incentives in such a manner that participants collaborate in a particular manner and you don't have to trust anyone, right? All the things would work as they should. And then preserving rights. So let's say you signed into a provider, let's say a banking provider or an identity provider, but companies can change terms of service and how they use your data, right? And what is the solution? Solution is, what if you could enforce the rights in code and it becomes impossible for anyone to be able to play with those rules or change those rules? I think this is something very interesting to me, right? So what we say in the blockchain realm is we say code is law, which means however the code is written, it will do whatever it does, and it's not possible to change it. And then inclusion. So when you try to open a bank account, right? Even in like urban cities, it might be easier. It's easy to open like a Paytm bank account and things like that. But traditionally, if you think about it, in villages, you still have to go to a branch of the bank to be able to open a bank account. And then how do you get loans? You need to have a good credit history and all of that, right? So what happens is half of the world does not own a bank account. What if you could make it easy for anyone to own a bank account, right? If you have a phone, you have a bank account. Why not make it that simple? So the solution is no need for bank accounts, credit scores, or age requirements to transact on a blockchain. Blockchain is permissionless. Anyone can become a part of it. And what we're looking at is infrastructure inversion. So there were bullock carts, but people didn't want cars. They wanted faster bullock carts. But when there were cars, people realized that, oh, okay, they didn't really need bullock carts as long as they have cars. And this is an example. So when Uber came along, taxi drivers said that Uber won't work. Hotels said that Airbnb won't work. Cable TV guy said that Netflix makes no sense, right? And similar. So I think we are at a stage where banks are saying Bitcoin doesn't make sense, but it's about the incentives. So Bitcoin or Ethereum is like, what they are trying to do is they are trying to uproot these banks. They are trying to reinvent finance, and because there are no incentives for banks to believe in this concept, and that's why they say that it wouldn't work, but it probably would. And blockchain is anti-disciplinary. So what that means is blockchain combines elements from economics, math, computer science, and philosophy, right? Computer science because cryptography, your hashing functions, math because again elliptic cryptography, probability, and your entire internet stack. And there's economics. So there's so much discussion on what the economics of the of a particular blockchain should be, which means what should be the inflation rate, how should we align the incentives, and there's the major part of it is law, which is how do you bring about this harmony with the regulatory bodies, and then there's philosophy. So the thing here is, do you really need blockchains? Do you really need Bitcoin or Ethereum? So this discussion is about this cyberpunk movement where people say that they have a right to privacy and freedom. And there's a very interesting book called No Place to Hide by Edward Snowden. And that throws light on why do we even need privacy and how, so if our privacy is not respected, it is often abused in the name of trying to protect you from terrorism and intelligence and all that. But often your privacy is compromised for serving vested interests. And anti-disciplinary means belong to one it does not belong to one particular discipline. As I said, it's like so much, and everyone can be a part of the conversation. So if you're interested in any of these fields, we need you. Blockchain needs you. And yeah, so that's it, guys. Okay, guys, thanks for watching, and all the best for the hackathon and your blockchain journey.